Hello everyone. Today in our video clip I'm going to show you how to work with logarithmic and exponential equations. So first of all, let's recall some formulas, some basic formulas for log expression. So we have this one. If you have a log of some product, m times n over, say, p times q, as I mentioned before, or log base any base a, and of course the base number is going to be positive and different from 1. Alright? If you have any factors on the numerator, you break it down, it's going to be plus. And if you have any factor on the denominator, it's going to be a minus in front. So this, break it out, becomes log base a sub m plus log base a sub n minus log base a sub p minus log base a sub q. Just make it that way for me. P and q on the denominator. It's minus. M and n on the numerator. Let's go with plus. Okay? And another one that you guys are going to use a lot is the exponential one. Log base a sub, say, m raised to the r exponent. This is a base number. And what you can do with the exponent is, think of it this way. Take the exponent now, put it in front. So this is equal to r times log base a sub m. With those two basic formulas, I claim that you're going to take care of quite a number of log equations, log problems that you may see. Okay, so in section 3.3, they're going to give you a bunch of exercises, help you to practice to get along with the formulas. And after getting along with the formulas, in section 3.4, you guys are going to start solving some equations involving log and exponential. Okay? So let me start with an example on 3.3. Just look at the book. Alright, so I see this. Log base 3 of x minus 1, x plus 4 over x squared minus 4. So base 3 is good, right? On the top you got two linear factors, x minus 1 and x plus 4. Bottom you have a quadratic, x squared minus 4. But we see that x squared minus 4 is factorable. So you need to factor this out. You got log base 3 of x minus 1 times x plus 4. X squared minus 4 can be factored out as x minus 2. I say 2. And then x plus 2. Now you see it's applied to the formula right here, right? Log base 3 of factor times factor divided by another factor times another factor. So if you want to simplify the log, and keep in mind we're not solving for anything yet, okay? We're trying to simplify the log. In this type of problem, they try to ask you to break a big complicated log down into the sum of different of small logs. So we have what? Log base 3 of x minus 1. It's on top, so it's plus. Plus log base 3 of x plus 4. Still plus because x plus 4 is on top. Now x minus 2 on the bottom. So what? Minus log base 3 of x minus 2. Of course, another one. Minus log base 3 of x plus 2. Okay. So that's an example. Let me give you a couple more before I move on to 3.4. How about this? Log of x cubed over square root of x plus 3. If you don't see the base number right here, recall what we talked last time. This indicates that we have a log base 10. Okay? And we have a fraction. On top is x cubed, on the bottom is square root. And this is how you convert from radical to exponential form. Square root of x plus 3 is actually the same thing as x plus 3. Everything raised to the 1/2. Square root means 1/2, but cube root means 1/3. Okay? So you have it that way. You can rewrite it as log base 10 already. X cubed over x plus 3 to the 1/2. Okay? Now you have a fraction, whatever on top goes plus, bottom goes minus. So I got log base 10 of x cubed minus log base 10 of x plus 3 to the 1/2. Now we have two single logs with exponent. What can we do with the exponent? We can bring the exponent out in front. So this is 3 times log x minus 1/2. It's 3 out in front. 1/2, bring it out. Log of x plus 3. And I think this problem required x gotta be greater than or greater than 3, negative 3. Greater than 3. Greater than 0 would be good enough. The book didn't say anything. Okay. How about one more example of this type before I move on? Okay. Doesn't matter how big or how small the big fractions, all you have to do is what? Try to factor out everything on the numerator, factor out everything on the denominator, and then that's to say whatever factor you got on numerator to bring it out becomes the plus sign. Whatever is on the denominator is going to be a minus sign. I'm talking about a factor. And the exponent can be brought out in front. Okay, let me look for a more complicated example. Okay. All right, I have this. ln of cube root of 2x plus 1 times x plus 1 over, let's choose something that's square root of x squared plus 1 times x plus 2 raised to the negative 5 times x minus 3 squared. Okay. In here we see that we have like 2 factors on the numerators and we have 3 factors in the denominator and we have radicals. So let's first convert the radical back to exponential form. We have 2x plus 1 cube root means raised to the power 1/3 times x plus 1, and the bottom is x squared plus 1 to the 1/2 times x plus 2 to the negative 5 times x minus 3 squared. There are a couple of ways to take care of that negative 5 exponent right here. You can bring it to the numerator and change from negative to positive one way, or you just simply work directly from here. That'd be fine. Now break it down. So whatever on top, ln 2x plus 1 to the 1/3 plus ln x plus 1, go plus sign. Whatever on top, go plus. Now bottom, minus ln x squared plus 1 to the 1/2 minus ln x plus 2 to the negative 5 minus ln of x minus 3 to the second. Okay, you break it out into single logs. Now you bring the exponent out in front. Put the exponent in front and we're done. So let me just cheat a little right here instead of rewrite everything. It's 1/3. Bring it outside. Let's just write the whole thing, right? So 1/3 ln of 2x plus 1. The second ln, nothing to do with, so leave it alone. 1/2 outside, negative 1/2 ln of x squared plus 1. Okay, here comes this one. We got a minus, right? We bring the negative 5 outside, so minus of negative 5 ln of x plus 2. And let me simplify this right here. So you see minus, the negative number is no more than plus 5. You can go that way, be faster. Ln right here. And then minus 2 times ln of x minus 3. Okay? So I try to, we have a lot of formulas, but I try to bring to you the 2 most popular ones that help you to simplify the log equation. Whenever we have factors on the numerator, bring out becomes the sum, denominator becomes the difference. Okay? And the exponent, bring it outside the log, put in front. Okay, now the second type of simplifying the log you may see is backward, what we're doing right here. They may give you a bunch of small logs, they ask you to put them back together. That's a big one, it's just backward procedure. So let me give you a couple examples of those. Okay. I think we can work with a big one. Let's see. I have log x, oh, they're using base 10, okay? Plus log of x squared plus 1 minus log of x minus 1 and minus log of 2x squared plus 3. Alright, put together. Now we see what plus sign, bring it together, inside becomes the numerator, minus in denominator. So this is equal to log, this is plus, right? So it's x on top, plus x squared plus 1, minus, so it's going to be in denominator, x minus 1, minus again, the other one on the denominator. So 2x squared plus 3. Done. Now let me make this problem a little bit more complicated. Just a little bit more. What if, instead of giving you this, I can put some factor in front. Say 2 here, 3 here, 1 here, and then how about 1/3 here? You know what happened to the number in front? You simplify, you bring it inside, become the exponent. So that 2, bring it back in, becomes x squared, 3 becomes cube right here. This 1, so it's alone, and 1/3 is cube root, so 1/3. You can write 1/3 here, or you can write cube root, either way. That'll be it. Next, let me move on to solving for log equations and exponential equation. We are in section 3.4 now, guys. Let's start with the log equation. Solve for log equations. Okay. Solve for x. Say I have this. Solve for x, okay? Solve for x. And this is what I see. Log, yeah, base 6. Make sure I copy it right. X plus 2 plus log base 6 of x minus 3 equal to 1. Okay? You have an equation involving the log. Most of the time, you try to get rid of the log. How to get rid of the log? Try to have all the logs on one side equal to number on the other side. Okay? And use a definition. So let's first of all combine the two logs in here. As we learned before, a log plus a log with the same base, you can rewrite it as log base 6 of x plus 2 times x minus 3 equal to 1. Okay? Log plus a log, break it down, becomes 2 log. Put it back in, becomes 1 log with product of 2 factors inside. Okay? And now let's recall the definition. This is very important, guys. This is the backbone of our section. You don't get a definition, very hard to get things right. Definition of log say what? You have y equal to log base a of x. What does it mean? This is the base number. Raised to the exponent equal to whatever inside of the log. So a to the y equal to x. Okay? We're going to apply it in here. Base is 6. Exponent is 1. This means what? x plus 2 times x minus 3 equal to 6 to the 1. Okay? Now you multiply them all out, combine the like terms, and simplify. This is what? X squared minus 3x plus 2x minus 6 equal to 6. You see that we have a quadratic. Subtract the 6 on both sides, combine the like terms. We have x squared minus x minus 12 equal to 0. Now, you can use quadratic formula and just simply factor. I can see that this one is factorable. We can factor this. X minus 4 times x plus 3 equal to 0. You have two equations, x minus 4 equal to 0, or x plus 3 equal to 0, x equal to 4, or x equal to negative 3. Okay? Those are two possible solutions. They may not be all solutions for the problem, because one condition for the log that you have to check is what? Based on the probability of the log, the whole thing, whatever the number inside the log, needs to be a positive number. So you have equations right here. Make sure that x plus 2 needs to be a positive number. And also x minus 3 needs to be another positive number. So let's check. If x equal to 4, 4 plus 2 is equal to 6. Positive is good. 4 minus 3 is 1. Positive is good. But for negative 3, what happened? Negative 3 plus 2 is negative 1. So negative 3 will not be a good solution. Same thing here. Negative 3 minus 3, negative 6. So actually, among the two possible solutions, this is really a solution. This is not. Okay? So solve for a log equation. We use some technique right here. We use the definition. And after having the possible solutions, make sure that you check, see which one's really a solution. Try another one. Solve for x. This time I'm giving you this. Log of x minus 1 plus log, minus, plus x plus 2. Let me double check that. Log of x minus 1 plus log of x plus 2 equal to 1. All right. Same idea. The only thing that changed in this problem compared to the previous problem is what? The base changed, right? This is base 10 instead of base 6 like before. And of course, simplify the two logs. Combine becomes 1. You have log of x minus 1 times x plus 2 equal to 1. Okay? You don't see the base, but LOG means base 10 right here. So use the definition. Base number raised to the exponent equal to whatever you have inside the log. So base 10 raised to exponent 1 going to be equal to x minus 1 times x plus 2. Same idea, same step as before. Multiply them all out, combine the like terms. I got x squared plus 2x minus x minus 2 equal to 10. This time we got x squared plus x minus 12 equal to 0. See how we solve a quadratic. Everything on one side equal to 0 on the other side. Alright? So it's x plus 4, x minus 3 equal to 0. So you have x plus 4 equal to 0, or x minus 3 equal to 0. Two possible solutions, x equal to negative 4, or x equal to 3. And again, plug in and check. Negative 4 minus 1, negative 5. Not good. 3. 3 minus 1 is 2. 3 plus 2 is 5. Yes. It should be good. And it's going to be log 2 plus log 5 is log 10 equal to 1. That's correct. Okay. Try another example. log base 2 of 3x minus 2, log base 2 of 3x minus 2, minus log base 2 of 5x plus 1, log base 2 of 5x plus 1, and that's equal to 3. Solve first. So in this example right here, we have base 2, but it's not adding two logs anymore. Now what? The first log subtract the second log. According to what we learned before, you have a log minus another log. You want to combine them together. It's not becomes a product anymore. It becomes a fraction. Okay? So this is log base 2 of 3x minus 2 over 5x plus 1 equal to 3. Apply the same definition that we have. After you have a single log equal to a number, base 2 raised to the exponent 3, 2 to the third power is going to be equal to the fraction. So 3x minus 2 over 5x plus 1. Okay? And 2 to the third is equal to 8. 2 times 2 times 2. So what we have in here is 3x minus 2 over 5x plus 1 equal to 8. Solve for this. Multiply both sides by 5x plus 1. We got 3x minus 2 equal to 8 times 5x plus 1. Multiply them all out by the like terms. 3x minus 2 equal to 40x. 8 times 5 is 40x plus 8. Okay? Let's combine the like terms. Let's subtract the 40x on both sides. Subtract the 40x on both sides. And add 2 on both sides. We have negative 37x equal to 10. So x equal to 10, negative 10 over 37. And don't forget to check, okay? It's just a possible solution. Negative 10 over 37 times 3 is a negative number, minus 2 is going to be another negative number. As to say, when we learn in section 3.2, we talk about property of the log. Anything inside the log needs to be a positive number. We don't even take 0. Got to be positive. If it's negative, not good, so this will not be a solution. Okay? So what do you say in this problem? No solution. Okay? We'll try another one. Last one for this section. And I think that'll be good for the log. And I'm going to move on to exponential equation. Okay. Try this. Log base 4 of square root of x plus 3 minus log base 4 square root 2x minus 1 equal to a quarter. Alright. Now we have log base 4, we have subtraction minus right there, we have square root. So first of all, we're going to convert that square root to exponent 1/2. Alright, and then we combine them, or we can do two-step ones because we've been practicing quite a number of exercises already. So on the left-hand side, we have log base 4 fraction. The top is x plus 3 to the 1/2. The bottom is 2x minus 1 raised to the 1/2 as well. And everything equal to 1/4. You guys see that I've been doing two steps in ones. I can break that radical back to the exponent, and I combine the two logs, and it's a difference. Subtraction becomes a fraction. Okay, now I'm going to use a definition. 4 raised to the 1/4 base raised to the exponent going to be equal to whatever inside the log in here, x plus 3 to the 1/2 over 2x minus 1 to the 1/2. Okay, question now is, how do we simplify this problem? There are many ways for you guys to think of it. 4 to the 1/4 is use square root of 2 or 2 to the 1/2 and you raise to 1/2 both sides. That would work, or just simply raise both sides to the 4 exponent. I think 1/2 is better. 4 to the 1/4 is 2 square to the 1/4, which is 2 to the 1/2. Okay, so everything got exponent 1/2, and all the factors are positive, so we can get rid of 1/2. Let me rewrite it in here. X plus 3 to the 1/2 over 2x minus 1 to the 1/2 equal to 2 to the 1/2. Square up both sides, guys. We have x plus 3 over 2x minus 1 equal to 2. And you know what to do from here? Multiply both sides by 2x minus 1. I got x plus 3 equal to 2 times 2x minus 1. X plus 3 equal to 4x minus 2. And combine the like terms in here, add the 2 on both sides, subtract the x on both sides. We got 5 is equal to 3x. So x equal to 5 over 3. And don't forget to plug in and check. 5 over 3 right here, plus 3, yes, positive, good. What? 5 over 3 times 2 is 10 over 3 minus 3 over 3. Positive. So if your algebra is correct, you should have a solution of x equal to 5/3. Okay? So we have a couple of examples. I'm just trying to show you some typical exercises involving the log equations. Let me move on to another topic in section 3.4. This time I'll be talking about equation involving exponents. Okay? Again, through softmax. Let's see. We're going to have something like this. 2 raised to the power of 1 minus x equal to 3 to the power of 4x plus 6. I'm just copying exercise from the book. Put it on the board. Okay? And you see what? The x, the variable x, the unknown x is on the exponent. And you want to solve x on the exponent somehow, you try to bring the exponent down. And the best tool to help us to bring the exponent down is applying the log on both sides. Okay? And you guys are free, we are free to choose the base number. Choose any base you like as long as the base number is positive, different from 1. And the most popular base number people used to use is base e. Okay, so let me do base e in here. ln of 2 to the 1 minus x equal to ln of 3 to the 4x plus 6. You see what's so nice about applying the log both sides? 1 minus x exponent, you can bring it out. 4x plus 6 exponent, bring it out. So on the left hand side what you got is 1 minus x times ln of 2 equal to 4x plus 6 times ln of 3. Alright, now it's just actually a linear equation because ln of 2 is no more than a number, it's a decimal one. ln of 3 is another decimal number. So factor out 1 ln of 2 is ln of 2